Welcome to the next session on finite element analysis. In this session, we are going to discuss about the advantages of finite element analysis. FEA offers several advantages in the field of engineering and design. Here are some key benefits. Predictive analysis. FEA allows engineers to predict the behavior of structures and components under various conditions without the need for physical prototypes. This predictive capability is crucial for optimizing designs and ensuring that products meet performance requirements. As we have discussed previously, that FEA is a non-destructive type of technique. Initially, when FEA was not there in the market, people used to first make the prototype, test it. If it would fail, they would again go for making of the prototype and they would continue the process till they would attain a good result for say life or the stress bearing capacity or factor of safety, whatever is required. But today, due to FEA, what you can do is you can create a model in ANSYS. You can also go for testing and see when it is going to fail, such that you can make the product with proper dimensions, material properties, and with no cost involved in analysis. You're just going to use the software to analyze and predict its life, its factor of safety, and everything. The only cost involved is in the setup of the software and the hardware. But that is something which is a long term investment. But when you see the long term goals also associated with it, then the price would not matter over a long period of time. So that is why predictive analysis is very important and it is one of the major importance of FEA, which has made designing, testing, everything much easier, and you can directly go for manufacturing of the product and its testing and validation, and the product will be in the market in no time. So the time required for the product from its conception to directly coming into the market is going to reduce. The time reduces and you are giving better products at lower cost. Cost saving. By simulating the performance of a design in a virtual environment, FEA reduces the need for extensive physical testing and prototyping. This can lead to significant cost savings in terms of materials manufacturing and testing. So I just gave you the explanation for cost saving, which is included in predictive analysis. Time efficiency. FEA enables rapid design iterations and evaluation, accelerating the product development cycle. Engineers can quickly assess different designs, alternatives, make modifications, and analyze impact on performance without the time constraints associated with physical testing. So it's the same explanation which I have told you in detail. So time is also going to reduce for the product development cycle. That is, from the conception of the idea to the product being in the market, the time required is going to reduce. Optimization of designs. Engineers can use FEA to optimize designs by systematically varying parameters and assessing their impact on performance. This leads to more efficient and lightweight structures that meet design criteria while minimizing material usage. So, when you are going for FEA analysis, you are already making an estimation of all the parameters required. Say what material you are going to use that is going to give you better strength. You will also check the weight of the product that you have created. So, in the process, you are going to make products which are more efficient and lightweight. So that will help you design better, and it is also going to reduce the material that you are using because you are making structures which are lightweight. Visual representation. FEA provides visual representations of stress, strain, deformation, temperature distribution, and other physical quantities. This is something we have extensively discussed in FEA, where we have gone through all these terms. This visual feedback enhances the understanding of how a structure or component responds to various loads and boundary conditions. So you apply any boundary condition, you would come to know what will be the response of the system to the given boundary condition. So without even applying them in the real life, you can see the effect on it, you can calculate what will be the deformation, stress, strain generated, and accordingly you can go for manufacturing of your products. Improve safety and reliability. FEA helps identify potential failure points in a design, allowing engineers to make adjustments to enhance safety and reliability. This is extremely important because the life of the product is very important, and also people who are using the product should feel safe while using it. So when you have a product in the market which is very safe and very reliable, then people will tend to buy the product. And as a company, if I am selling the product, I will be in profit over a period of time. The reason is I am providing products which the customer wants, and also it is more reliable. This is particularly important in critical applications such as aerospace, automotive, and structural engineering. So any product which we use in the market should be safe and reliable for the customers. Multiphysics simulation. FEA can simulate the interaction of multiple physical phenomena such as structural mechanics, heat transfer, fluid flow, and electromagnetic fields. This capability is valuable for analyzing complex systems that involve coupled physics. Now, suppose if I want to analyze a particular beam for its structural capability, and I also want to know what would be the effect of temperature change on that beam, because the beam will be made of some steel material inside. So I want to know the effect of both load as well as temperature. So when you are using two different modules, that is structural and you're using thermal together to know the effect of one on another, it is possible that because of temperature there will be some stress strain induced in the body. You have already studied this in strength of materials. So if I want to know that apart from the load applied, what will be the effect of temperature also on that body which is inducing some stress strain, and what could be the failure because of it. So you can first study the thermal analysis of the beam, and then you can go for structural analysis. So you are adding the temperature and the load parameters both, and then coming to a conclusion as to what will be the effect on the beam. This is called as coupled physics, and in ANSYS this is called as multiphysics simulation. Parameter sensitivity analysis. FEA enables engineers to perform sensitivity analysis to understand how changes in design parameters affect the performance of a structure. This information is valuable for making informed decisions during the design process. So you can go for sensitivity analysis as well in ANSYS, such that you come to know what would be the factors which are affecting the structure and its performance. It will help you make a design which is more robust and which is going to stand the test of time. So you need to go for this type of analysis also while making of a design. Virtual prototyping. FA serves as a virtual prototyping tool, allowing engineers to test and refine designs in a digital environment. This reduces the need for physical prototypes and associated testing, leading to quicker and more cost effective product development. So we are mainly going for the software which will create an effect and show you what will be the stress and strain, or it could be some heat flow through the wall, or say some fluid flow. You can calculate lift and drag in aerofoils. So you can create an ambience and check the effect over the body, and you can go for its testing but online. You don't have to go for a physical testing and waste materials by using destructive testing. So this type of non-destructive testing is always helpful in the long run. Environmental impact assessment. Engineers can use FEA to assess the environmental impact of a design, including factors such as energy efficiency, thermal performance, and material usage. This aligns with the growing emphasis on sustainable and eco-friendly design practices. So, after all these discussions, we definitely know now that FEA is a very eco-friendly and sustainable type of a technique. So let's discuss the summary of this topic. Overall, FEA plays a crucial role in modern engineering by providing a powerful and versatile tool for design validation, optimization, and decision making. So these are very important terms which are used in the companies wherein design validation is required. Only then you can go for the production of it. Optimization is very important because you want to use minimum material, lightweight structures. You want to have longer life. You want to have products which are safe and reliable. You also don't want to waste a lot of money in manufacturing and testing again and again. This will also involve some labor cost, who is going to prepare and make the products for you. So these kind of costs are also reduced. So optimization in terms of money, labor, energy, everything is involved. So everything can be optimized and you can get better designs. And this definitely helps you in making better decisions as to whether the company must go with the product or it should discard this kind of a product that they have created. So with this, I end the session. I hope you have understood the lecture. If you have any doubts, please write to me in the comment section. Don't forget to like, share, and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.